Hello, hello. Good to see you and welcome to my second YouTube video. In my first YouTube video, I talked about async programming in Shiny and I demonstrated how to do that with two packages, callr and crew. I got a lot of positive response on that video, which I have to thank you for. And I found it really exciting to see everybody getting hands-on with async programming. I saw a lot of people actually trying out crew. And with that also came some questions because people wanted to apply crew in real life and they encountered scenarios which might be useful to explain a little bit further. So that's why I decided to record a second video about crew, and this time we're going to learn two things. One, you're going to learn how to use crew to send multiple tasks to a crew controller and obviously retrieve the results. And two, you're going to learn how to create a dynamic UI so you're not bound to a certain number of outputs. Let's go. If you didn't watch the first YouTube video about using crew and callr, don't worry, you can still follow along with this tutorial. I will give a short recap about the crew app and I will demonstrate what it is all about. This is our beautiful Shiny app. Don't pay too much attention to the UI because I didn't as well, but the point is async programming here, not UX design. So this app is about a single task. In this app, we will use async programming to keep the app responsive, meaning that the app doesn't freeze while it is doing a lengthy computation or retrieving a lot of data. The app is super simple. On the left-hand side, we have some inputs like a company ticker and a date range, and a button that will retrieve stock data, so it says. And on the right, we have two outputs, namely a status message, which now says no task submitted yet, and we have a plotting canvas. If we retrieve the data like this, we will retrieve stock data using the Yahoo Finance API, and that will take approximately 5 seconds. And when the task is finished, we will get the results. Now, I don't know if you paid attention to it, but the clock that was ticking on the progress message was of use. So let's do it again. Let's say I select ING now, we get stock data and we see a clock ticking. You will notice that the clock keeps ticking even though the tasks get executed. This means that the app doesn't freeze and stays responsive for your users, just like we want it. So let's quickly go over how this actually works. If you've seen the first video, you may recognize this function, and if you didn't, well, you get acquainted with it now. This function is called the run task function, and this function retrieves data from the Yahoo Finance API. Now, this API is really fast, so we have to simulate kind of a long retrieval time with this very complex system sleep function. I'm not going to pay too much attention to this function. If you want to know more about it, you can check it out or watch the previous video. But in essence, it retrieves data as JSON, then parses it into something that we can use, retrieves the prices on a given date, and then makes a ggplot out of it. In the app, we also have another function, which is the status message, which keeps track of the number of tasks that are being executed in the background, and it will also give you an update when all the tasks are done. The UI is super simple. We have some inputs like the company, the date, and we have an action button, and we have some outputs, namely a status message and the actual plot. On the server side, we have some reactive values and outputs, and then here we have the crew part, which basically initializes a crew controller with 4 workers. You can change these settings if you want to, but for this example, we've chosen 4 workers and an idle time of 10 seconds, meaning that if the workers have nothing to do for 10 seconds, they will automatically shut down. And here we start the controller. Then also noteworthy is this onStop function. This onStop function makes sure that we close down all the workers when the app stops as well, because otherwise you might be stuck with a lot of ghost processes on your computer, and we don't want that. Then this observe event is what does the real work. So when we click this button to retrieve the stock data, then we push a certain task to the crew controller. Now, we have to be aware that this task takes place in another environment, in another R session. It doesn't know anything about the main Shiny session that is running. So we have to give it arguments like the data that we want to pass along and the packages that we want to load in this new child R process. When we have pushed the task, we will set this reactive value called reactivePoll to true, which will then trigger this observe or invalidate this observe every 100 milliseconds. To retrieve the results from a crew controller, we simply pop the results and then we store them in this reactive results object. Here we also print something that gives useful information, but we can omit that at a later stage. Also, we update the status message and we set the reactive poll value to false again when the controller is empty and the task is executed. Now, many of you asked a question on how to send multiple tasks to a crew controller and execute them in parallel. Because how nice would it be that if you cannot only select one company here, but multiple companies and retrieve the data at the same time? So we might want to select Adyen and ASML together. So this also means that we want to speed up our app in a certain way. Because if a task takes 5 seconds to execute and we want to do that twice or 3 times or 4 times, then obviously it's also going to take much longer to execute. So let's say if we want to retrieve 2 companies, then it's going to take 10 seconds to execute those tasks in a queue. And async programming is there to solve this queue and execute the tasks in parallel on another location or in another R session. So how can we change the app that we currently have to do that? Let's get into it. First things first, we need to be able to select multiple companies and not just one. So we're going to our UI. We here have this select input, and to make it a bit more readable, I'm going to put these on new lines. And what we want to do here is we want to allow users to select multiple choices. So we set multiple to true, and we default select to, let's say, Adyen and to ASML. Just to make it easier, otherwise we need to, for demonstrating purposes, we need to select multiple companies every single time we go into the app. So that's done. Now we can head over to the server part. Let's first start with the function or the observe, where we push the results to the crew controller. Because now instead of one company and one task, we want to push multiple tasks for multiple companies to this crew controller. We can simply do that in a for loop. That's not that difficult. So we can just say for y in 1 to length input companies. So for every company basically called I want to push something. So we're just going to put this whole chunk in the for loop. Now, obviously, I need to make some adjustments. Let's first start with fetching the name of the company a particular task is actually about. So we can simply assign a variable called a symbol to the company that is currently in that for loop. Just to double check, I think this is actually company and not companies. All right, so we need to change that. All right, and then here, instead of this input company, I want to use this symbol. Now, what I didn't tell you last time was that instead of these, or besides these command, data, and packages arguments, there's also another argument that you can use, and that is called name. So basically, this name argument is going to help you to organize the results. So each of the tasks you can, and the results, you can give a name. In this case, we simply going to give every task and every result the name of the company that the results are for. So we just do it like this. For the rest, we don't change anything. So now in this loop, we have pushed multiple tasks to the crew controller. And as soon as we push them, we set this reactive poll to true, which will trigger then the next observe. Here, we do need to make some changes because currently we pop a result like once and we store it in a single reactive value, but we want to change that. So let's do that. First of all, I want to do it a bit differently here because we don't necessarily have to extract the result from the object here. So we can remove that. Also, I'm going to get rid of this print statement just to keep everything clean. And how does this actually work? Because we can see the crew controller as kind of a manager that holds all the tasks. When a task is finished, we can pop the result. And we can pop as long as there are still unpopped tasks in the crew controller. So we can pop them one by one, meaning that we can let this observe invalidate every 100 milliseconds until the whole crew controller is empty. So until this is false. So we don't necessarily have to change much about this. The only thing that I want to change here is that every popped result I want to store somewhere else. I'm actually going to make another reactive. I'm going to change it. So I'm going to change the single reactive value into reactiveValues. And I will just initialize it as empty. And then I have these reactive results object, which I can then use to store all the results in. So every time I pop a result, I want to store it in the reactive results with the result name, which is the name of the company or the company ticker. And in that list, I want to store the actual ggplot that is coming from it. So the actual ggplot is coming from the result, which will contain another object called result as well, and then the first element. This you just have to know, and you can use obviously a browser to inspect what the result looks like when you're running the app. So that's that. This we can leave. We can leave the status update. We can leave this. So as if everything is empty, then this will return false, and this will stop invalidating every 100 milliseconds. Okay, so our results are now in a reactiveValues object. What else do we need to change? So we have pushed for every company a task, we have collected the results. Obviously, we need to display it now. So what we previously have, I'm just going to separate this just to keep the code nice and clean. So we have reactiveValues and we have output. And basically, we're going to not get one plot, we're going to get multiple plots. And this can be one plot or two plots or maybe even 5 plots. We don't know. The user has full control over that. So we also want to make our code a little bit dynamic to be able to handle that. So what we want to prevent is kind of doing stuff like this. Because we could simply say, hey, we make objects for basically every kind of number of output as possible, and we go over. But this obviously is not very dynamic. It's not really bulletproof, and we can do that much smarter. So I want to do that with a render UI and UI output. So instead of all these individual stock plots, I want to do here a UI output instead, which will enable us to have multiple plots at a later stage. I'm going to call that plots. So this I won't need as well. What I do need, I need to render this UI at some stage. So at some stage, I need to say something like output plot is, well, render UI something. But what is that something? First, we need to make sure that the plots are somewhere. And to do that, I'm going to create an observe, which will loop over this reactiveValues object, which will have all the plots of all the companies that we asked for. I'm going to do it with a apply. You could also do it with a for loop if you don't like the apply family, but I want to do it like this because it's a bit more readable. And I'm going to loop over the names of this reactiveValues object, a reactive results object. And these names will be the company names or the task name or whatever you call it. And basically for every output ID is going to be this task name. So the ID of the outputs I'm going to generate is going to be the task name. And I need to specify that like that. It's going to be the task name. And every of this ID is going to have a plot, which I'm just going to plot with render plot. In the reactive results object with the task name as well, that will hold a plot because our function returns a ggplot directly. All right, so now I have created the output IDs. Now these plots have to appear on the screen as well in the Shiny app with plot output, and that is where this render UI comes in. So what I'm going to do here is I'm going to create a list, which very originally will be named plot output list. And this list is basically also going to have a apply, which is going to loop over the names of the reactive results object, similar as to what we've seen above, task name. And for every element in this list, I'm going to call plot output, with the ID being the task name here as well. So then I have a list of plots. Now, to actually plot them with render UI, I have to pull a little trick that not everybody knows. I need to put this list into a list of tags or a tag list. Like this. If all went well, I'm going to save it. If all went well, this should work. Let's go over what we just did. So we created a new reactive value object called reactive results, which will be our home to all the results that we retrieve. Then here we have an observe, which is going to take care of all the output and making sure that all the outputs have the correct IDs. And then this part is actually going to put the plots on the screen using render UI. Our crew controller didn't change. Our observe event with our input task did change because now the tasks are being pushed in a are being pushed in a for loop. And we've given each of these tasks a name, which is equal to the name of the company. And what we did here is instead of storing our results in a reactive value object, we're going to store it in a reactive values object with the name of the company again. Let's see if it works. So here's our app again. So now we are able to select multiple companies. One thing I did notice is that we can only select by default. There's only one company selected, and that's probably because I made a typo, because who doesn't make a typo when live coding? But the point is we can select multiple companies. So if I select Adyen here and ASML, and I would click get stock data, then we're now seeing that there are 2 tasks in progress. The clock keeps ticking, and hopefully, fingers crossed, there will be 2 apps or two plots on the screen, and that happens. So all good. So now we have Adyen and ASML on the screen, but if we want to add other companies like ING or KPN, we can just do that. And then we also see that there are 4 tasks in progress, and then these other 2 companies should appear below that. There they are. So that is how you use Crew with multiple tasks and execute them in parallel. There's still one little problem with our app. Let me show you what happens if we click Get Stock Data multiple times. If we do it the first time for one company, let's say Adyen, we would expect to see one plot in the app. And indeed, there's one plot. But what if we select now 2 other companies, let's say ING and KPN, and I don't want to see Adyen anymore? If I click Get Stock Data now, we would expect to see 2 plots, but what actually happens is that we get 3 plots on the screen. Adyen is still there, even though we didn't request it. So let's solve that. The results are stored in a reactiveValues object, which is kind of like a list, but it behaves a bit differently. The name of each element is the company name. Now, we can't remove elements from that object, from the reactiveValues object, like we can in lists and environments. We can only set the value of an element to null, but the name will always be there. And we don't set the value to null in our code, so even though we didn't select Adyen, for example, the plot will still show. But since we loop over the names of the reactiveValues object, it will still cause issues even if we would set the value to null. But we can solve this. With just a simple fix, we can make sure that we only get the plots that we requested. It might be a kind of hacky situation, but it works. What we can do here is, instead of plotting for every task name, so we loop here over the names of the reactive results, and since the names are always there, even for the companies that we didn't request, we still have that plot output here. So what we can simply do is have here a conditional statement. So if task name, it should be in isolate input company. And only then I want to have the plot output in my plot output list. And I am using isolate here because obviously this is a render UI. So whenever this would change, it would automatically change the plot output list and stuff will start flickering in the UI, meaning that elements disappear whenever you touch the input company selector. And I don't want that, so I isolate it here so that this doesn't invalidate whenever this changes. I could do the same thing here just to reduce a bit the computational burden, although it's not really noteworthy, but we can just implement the same thing here. So if the task name, if it is in the companies we requested, only then we will get it in there. And that's it. And of course, we have to see if it works. So we just do the same. We request Adyen as the first company. Then we have a 1 plot. And after that, we're going to select ING and KPN, but without Adyen this time. And then we should see only 2 plots on the screen, and Adyen should be gone. That's it. So the nice thing about this is that we now not only have a responsive app, it doesn't freeze, we also have a much faster app. Because if we would have executed, let's say, 4 tasks in a queue, it would have taken us 20 seconds, namely 4 times 5. But now with Crew and leveraging async programming, we can execute them in parallel, meaning that it will only take us 5 seconds plus some overhead time to execute these 4 tasks. Note the overhead time, because there will always be a little bit of overhead time involved with spinning up different R sessions and collecting the results. That's inevitable. In the case of crew, I've seen, well, anywhere between 0.3, 0.4, 0.5 seconds like that in overhead time. And I also need to give a disclaimer, and I said this multiple times, and I'm going to say this multiple times in the future as well. Async programming is not magically going to make your code run faster, because our function run task takes 5 seconds to run, or actually it's sleeping for 5 seconds. If I do that somewhere else on another R session, it doesn't mean that it's going to do it there any faster. It's still going to sleep for 5 seconds. So in the basis, this run task function is not going to be faster by async programming. But just because instead of executing tasks in queue, we can now do it at the same time, it will sometimes give you a speed gain. Hopefully you learned something today about using crew to handle multiple tasks and to execute tasks in parallel. And at the same time, you hopefully learned how to create a dynamic UI and create a dynamic number of output elements in the user interface of a Shiny app. If you want to see more examples about async programming, I encourage you to take a look at the GitHub repo async Shiny, because there are many examples about async programming. We have examples with Mirai, also with future promises, call R obviously, and multiple examples with crew. There's also a discussions a platform now, or how do you call it, a discussions place, where you can open discussions with other fellow R programmers, and hopefully this will make it easy for you to ask any questions that you have about async programming or to get help. Hopefully you enjoyed watching this video, and hopefully you're going to get hands-on with crew again, and I can't wait to see all the results. Thanks, and see you next time.